Our final example hits the last objective, and that is to use sum and difference identities to solve trigonometric equations. So we're going to use our trig identities to help us solve equations on the interval from 0 to 2 pi. And we have the cosine of the sum, and we have the sine of a difference. So we start this problem off by using our cosine of the sum identity, which means we have to take the cosine of the first angle times the cosine of the second angle. Then we have to subtract the sine of the first angle times the sine of the second angle, which is pi. So I've just evaluated this by using the cosine of a sum. Then we're supposed to subtract from that, so minus the sine of a difference, which means you take the sine of the first angle times the cosine of the second angle, then minus cosine of the first angle times the sine of the second angle equals 0. So we want to find all the values where this is equal to 0. Then we're going to do some evaluating. Pi is a quadrantal angle that's pretty simple to find the value of. Here's pi. It's resting right on the ordered pair -1, 0. So here's our cosine value of -1, and their sine values are 0. So the cosine of pi is -1, so it's going to be the cosine of x times -1, then minus the sine of x times 0, minus cosine of pi is -1, so sine of x times -1, minus the cosine of x times the sine of pi, which is 0. Now I'd like you to put in those zeros and -1s so that you can show your reader of your proof or of your equation what you're doing. Be very articulate in how you tell people what's going on in your equation. So this will end up being a negative cosine of x. Okay, now this one we have is minus 0, minus the sine of a -1, or must have been cosine of x. I had to have left out the x, so sine of x, negative, then minus 0, had equals 0. So this is the one that I left out, the sine of x, without having to rewrite and redo. So this is a negative cosine of x. The minus 0 we can eliminate, the minus 0 we can eliminate, and a minus a negative is equal to a positive. So plus sine of x equals 0. And then we've got to figure out a way to solve this. So what we're going to do is we're going to isolate the sine of x on one side, the cosine of x on the other side. And there's really not a lot that we can do to that because there's no way to change a sine into a cosine, so we're going to have to think through the process of what angles are the sine and cosine values exactly the same within one rotation of the circle. So if we go in one rotation of the circle, where are the sine and cosine values identical? Well, one location is here in the first quadrant at a 45-degree angle, because you got a 1, 1, square root of 2. The sine value would be 1 over the square root of 2. The cosine value would be 1 over the square root of 2. Or we'd have square root of 2 over 2. For both positive. Now the only other place that happens where they're both positive is in the third quadrant. So if you think of 45 down here, that would be a -1. This would be a -1. This is square root of 2. So both your sine and cosine values would be negative square root of 1. Oops, -1 over the square root of 2. So both of them. So it's in the first quadrant and the third quadrant. The reason we have to eliminate the second and the fourth is because your sines would be opposite. If you think about going in the second quadrant, your cosines would be negative, but your sines would be positive. So the positive and negative wouldn't make them exactly the same. So we had to reason out more than just solving this entire equation of isolating x. So that means in the first rotation we have pi force and we have 5 pi force. Now in the example that the book had that goes along with this, they said you can definitely check these by looking at graphs. And you have a really good grapher now. I gave you that download to this Desmos calculator. I typed in the equation already. We want to see where it's equal to 0, so I'm just going to show you where the graph is. Within the first rotation, or between 0 and 2 pi, which is 6.28, there's only 2 locations. It's a pi force and 5 pi force. So therefore, we got graphical evidence that our algebraic method of solving this equation is accurate. So our 2 solutions are pi force and 5 pi force, and this was an example of using sum and difference identities to help solve a trig equation.